In this session, I'm going to look at the different kinds of measures that are typically employed or engaged for computing the investment risk. The more important reason why I look at this measurement of the risk is almost all the concepts that we use almost all the concepts that we use in the case of finance and investments, they drive they get driven by the underlying factors of risk versus return. So evaluating what is the expected return the security gives versus what is the risk that is involved in it. So that is one of the prime reasons I want to look at the various measures of risk so that we can evaluate the investors risk taking capabilities, and based on that map the appropriate investments to these investors. So from that dimension, here I'm going to look at a few measures along with their advantages and disadvantages. I would like to look at the concept of variance as a very common measure of risk, but along with that, we also will see there are a few other topics like semi-variance. There is something called shortfall probability, which is a measure of risk. Then we will be talking about a concept called value at risk, which is called as VAR in general. Then we also will be extending our discussion to understand what is called as expected shortfall or even tail value at risk. So we'll try to compute all these various concepts of risk, and based on that we'll see the advantages and disadvantages, what are the limitations of each of these measure, in what cases we can use one measure compared to the other. So these are the various things that we can look at as a part of the understanding in this specific topic. So just to get in, I want to start off with the variance, a very basic definition. The variance simply talks about the average deviation from the mean. So the way we try to find out that is, we find out the mean of any distribution. We first find the mean of the distribution. We subtract each value from the mean, and just to make sure that the negatives and positives don't offset each other, we take the square of it and we take the average of it. Or it is as good as I take the difference, square it, and multiply it with its corresponding probability density function. So so multiply it with its corresponding probability density function. That is what will give me the variance that is involved in the process. This entire thing either is integrated over the entire space, or if it is in a discrete form, I'm going to do the summation, because here in the discrete form I'll not use it as f of x. I'll try to use it as probability of x equal to x, and I'm trying to sum it up over I'm going to sum it up over all values of x, either of them. This is what we are trying to measure as variance. So probably just to understand this concept, I'm taking a data. Let's say these are the Sensex values right from 1st April 2013 to 31st March 2014, over a 1 year period. So looking at the values, looking at the Sensex values, have looked at the return, the daily return, which is nothing but the percentage change in the value from day 1 to day 2, day 2 to day 3, and so on. So these are the return. So what I can very well assume is I'll take a probability, the occurrence, the frequency of occurrence of each one of them. So I'll assume that all of them are having the equal probability of occurrence. So I'll do it as 1 divided by the counting of this entire list. So it is saying that the probability of occurrence for each one of them is 0.004. So overall it is coming out that the probability of occurrence of each of them is coming out to 0.004 itself. Now from that I would like to compute the mean, the expected return, which is nothing but I multiply the return by its corresponding probability and I try to add up all these returns. So probably if I want the mean return, I'm taking the average of all these things. So overall saying that the mean return is going to be something like this. Or probably I need to sum up all these. I can't do the average because I have already multiplied with the corresponding probability. So I am summing up, giving that the mean return is something like this. This is the mean return. So probably I am trying to establish it in percentage form. It is giving me that the mean return is around 0.07%. Now what we are saying is I subtract the mean from the each of the values and square it, right? I subtract the mean from each of the values and square it. So this particular return minus the mean I subtract and I do the squaring of it, and this I multiply it with the corresponding probability. And if I sum up all this, this is what will give me the variance. The variance is given by the summation of all the x minus mean whole squares, or probably integrating it over minus infinite to infinite if I'm looking at a continuous kind of a function. So in this case probably the variance is coming out to be something like around 0.01%, and probably if I am interested in standard deviation, I am simply taking the square root of the variance, which is giving me that the standard deviation is around 1.1%. So these are some of the common numbers that I can look at in this particular context. So for computing the variance, all I am looking at is the computation of the mean and then subtracting the difference and then taking the difference between the mean from each individual value, squaring that and multiplying it with the probability of occurrence and finally summing that up. So here couple of advantages I get through the computation of the variance is I can use it quite simply and easily in a mathematical kind of a framework. So probably easy to compute, right? And a lot of applications in the world of investment, they depend very heavily on the usage of the variance as a measure of risk. And so from that dimension, variance becomes one of the important tools. But however, people started questioning on the variance because variance is talking about the deviation from the mean both on the downside as well as on the upside. And what it is interpreted is generally people are more worried about the downside loss, but they are not that much worried about the upside loss or upside profit. So they don't really dislike this. Their dislike is only for this. So which means it is very much essential for us to compute the measure of risk, because here we are saying variance as a measure of risk. Anything upside, it is felt that people don't really look at it as a risk rather than something positive for them. Whereas if it is on the downward side, it is perceived as a big dislike to majority of the investors. And that's the reason one more measure has come out which focuses primarily on the downside of the returns from the mean itself, and that is what we are calling as the semi-variance. So here also we do the same thing. We take the mean, subtract it, subtract each and every value from the mean, square it, multiply it with the corresponding frequency distribution or the probability distribution, but here we integrate it only up to the mean. Only those values, only those values which are having a lesser than the mean, only those values which are lesser than the mean, I compute them and I integrate them. So even in a discrete form, yes, mu minus x squared probability of x equal to x, and here I will not integrate over all the x. I'll add up only over that particular x whose values are less than the mean. So which means here in case of semi-variance, my objective goes like this. I'll try to compute the same x minus mean squared, but this time I will take only for those whose value is lesser than the mean, which means if this particular return is lesser than the mean, then only I will take this computation, otherwise I will take it as 0. So because here this is 0.93 which is greater than the mean, I am not bothered about it. Now this is how I get my values. So based on this, if I am adding up, I get my semi-variance simply as the summation of this, which is showing me, if I am trying to put it in a percentage form, the semi-variance is saying 0.006%, whereas variance was showing 0.012%. Now, one thing that we may have to observe is if the distribution is more symmetrical, if the distribution of the returns is more symmetrical, what we see is the semi-variance will generally be around half of the variance itself, especially if the distribution is more symmetrical in nature. And it's not that easy to handle because we are doing the calculations only if the particular only if a particular return is lesser than the mean. It may not consider all the positive sides. So the variability above the mean is nowhere considered for the calculation of the semi-variance, and probably with the change of data the mean changes and some of the observations which were included earlier may not be included in the computation of the risk now, and it can happen the other way also. Some of the values which were not included earlier, they may come into the inclusion now. So one thing is, not all the data is taken into consideration for the measurement of the risk. Only those occurrences whose values are falling below the mean are being considered. But yes, otherwise this is one more important measure for the risk. And the third important measure that comes in as far as the computation of the risk is concerned is a shortfall probability, which is nothing but the probability that a particular return, the probability of the returns going lesser than a particular value, going lesser than a particular value L. The probability that the returns are going lesser than a particular value L. right? So all I'm trying to find out is, let's say I'm talking about L being minus 2%, right? L being minus 2%. When I'm talking about the shortfall probability in a continuous form, I'll try to look at it as minus infinity to minus 2%. What is the probability of f of x? Similarly, in a discrete form, I'll try to add up all those x's whose value is less than or equal or less than L itself. All the probabilities whose value is less than L is what will constitute my shortfall probability. I can define some kind of a benchmark, and anything that is below the benchmark is constituting my shortfall probability. So here if I am defining my benchmark, let's say as 2%. Now all I am saying is I am trying to count the number of days which have fallen below the 2% mark. So I am saying count if within this particular range the value less than minus 2%. A value less than minus 2%. If I am seeing there are 8 such values. So the benchmark I have defined as minus 2%. So I have 8 particular values whose return is less than minus 2%, which means I can call the shortfall probability is 8 out of the total. How many is 8 out of the total? What is the total for me? I have observed almost so many days and 8 out of them are falling below this. So the shortfall probability in this case expressed in percentage form is resulting into 3.2%. Means 8 observations have a benchmark, have a return value lesser than the benchmark. The benchmark I have set it as it can't fall below minus 2%. So because of that benchmark that I have set, I am observing what is the probability that a particular value has fallen below the benchmark. I can add up all those probabilities so I can add up. Probably I could have done another usage of sum if kind of a function. I could very well see within this the criteria being less than minus 2%. I want to sum up their probabilities. So it is giving me the same 0.032 or 3.2%. This is what we mean by the shortfall probability. Then one more concept of risk that we are bringing in this context is the value at risk. Value at risk is talking about more from, again, the probability of underperforming. It's a measure of the probability of underperforming or the value going below a particular layer itself. Now the way it measures it is the potential loss over a given portfolio or over a given time period with a particular degree of confidence, with let's say 95% confidence level. So this is more and more in terms of amount. So where we say that amount or percentage, whatever it is, which we say that the chances of the loss being beyond this, below this, the chances, the probability of loss being below this particular number is not more than 5%. If I am saying I am making this statement with 95% confidence level, it means that the chance of the loss being more than this particular decided level is just 5%. So I am defining that particular cutoff for the loss, saying in 95% of the cases the loss will not be more than this. Only 5% possibility exists that during this particular period the loss will exceed this particular amount. So that is what we typically represent the value at risk, saying the value at risk for this particular x is minus t, which means what the probability that the x goes below this t is going to be this particular. There is a p probability that the value of x goes below the t mark. Now that is what, if I want to find out here the way the var of x probably at 5% level of confidence, means I really want to find out the 5% of the value, right? Which means out of this I'm looking at, okay, what is the 5% of the value? If I want see, 8 of them are below minus 2%, it's only 3.2%. But I could look at how many, if I'm talking about 5% of the total values, which will work out to, let's say, around 12.5. So probably I am interested, let's say, in the 12th or 13th smallest. If I look at the 13th smallest value, I use a formula called small to identify the 13th smallest value here. It says around minus 1.8%. Now what I'll say is minus 1.81%, minus 1.81% is the 5% value at risk for this on a daily basis. Means the chance that the loss on any particular day, loss on a particular day is more than 1.81% of the invested value, the chance for that much of loss occurring more than 1.81% in a day is only 5%. Means there is a 95% chance that the loss will be less than 1.81% itself. It could even be a gain, but the loss cannot be more than 1.81% on one single day, going with this particular definition of value at risk. So whenever we are seeing here where we got the value as minus 1.81%, but we are saying that the loss is more than 1.81% in 5% of the cases. So if the value of risk is negative, if this value is negative, then it indicates a loss. If the value of risk is positive, it indicates a kind of a profit. So the value, this loss can again measure be in absolute sense, saying minus 1,810 if I have invested 10,000 or 100,000 bucks, or I could very well say it is minus 1.81% on any invested amount. So it could be expressed either in absolute terms or in relative terms compared to this particular benchmark. So this is one more way of measuring the investment risk. But the biggest thing is this particular concept of value at risk works more and more better if the distributions are more normally distributed. If the return distribution is normally distributed, this makes a lot of sense. But if the return distributions, or if the benefit based distributions are completely, if the payoff related distributions are non-normally related, especially if they have extreme value distributions, means probably if the profit is there, the profit is going to be exceptional, but loss is very much limited. Or the other way, especially in case of credit risk, kind of portfolios, if the loss occurs, the loss could be exceptional, but the profit may not be that much exceptional. Or when I talk about any kind of derivatives tradings where extreme values of losses are very much possible because of heavy exposure to them. So because wherever these kind of situations are involved, you need to really identify the underlying distribution, and based on that underlying distribution find out the appropriate probability density function, and based on that only we can compute the VAR. So the computation of the value at risk depends more on the underlying distribution. The effectiveness of the computation of the value at risk is very much depending on the underlying distribution, and because of that we need to take care, we need to model the underlying distribution quite effectively if we have to arrive at a better measure for the value at risk. And now the other concept is a clubbing of expected shortfall and the tail value at risk. Tail VAR is typically called as. Okay, VAR as simply said in the above example minus 1.81%, or VAR I will write it as 1.81%, mean there is a 5% chance that the loss in one single day is more than 1.81%. That is the only thing which VAR is telling me. It is saying that beyond 1.81% loss in one single day, there is only 5% chance of occurring. But it did not tell me what is that expected loss, what is that expected loss beyond 1.81%. It does not tell us what is the expected loss beyond this 1.81%. And that is what if I am setting minus 1.81% as my base, I am trying to find the average of all those losses which are below this minus 1.81%, and that is what I call as the expected shortfall, or probably tail VAR. So I know that this is the VAR, and anything below the VAR, beyond the VAR, what is that expected value? So basically I am looking at the average computation. I am looking at the average computation only of those values which are less than this minus 1.81%. I am trying to find out their average itself. So this has come out to around minus 2.5%. So I'm not doing the average of all of them. I'm doing the average, or I'm multiplying those particular returns with that corresponding probability only for those which are beyond that threshold level. Here if I am setting the threshold as the VAR itself, if I am setting the threshold, this minus 1.81% is nothing but the 5% VAR. So that is where I am getting this computation of the expected loss. I am calling it as tail VAR. But if this is instead of minus 81%, 1.81%, if I have set it to be minus 2%, and I am trying to find out the expected loss beyond minus 2%, because this is not a VAR value, value at risk value. This in general it is called as the expected shortfall, the expected values of all the losses below a threshold level. If that threshold level is nothing but a 5% VAR or a 1% VAR value, then that same expected shortfall is same as the tail VAR, tail value at risk itself. So these are different kinds of measures that are available with respect to measuring the risk associated with an investment security. We can apply them in different contexts for different kinds of situations, And as we move along, we'll see how these things help us in devising or designing the portfolios, or probably evaluating the various portfolios, or making appropriate decisions regarding the investment by assessing the appropriate risk and return of the various investment choices that are available. So this is what I would like to look at or discuss as a part of this particular topic. If you have any further queries on this, you can very well get back to me by giving me a call on the number that I have given below, or you can send in an email at vamsidhar@pacegurus.com. Thanks a lot for listening to this session. Thank you very much.